So it's called Null Island. So it is, okay, sorry. Go back. It's right out here, right? It is 380 miles south of Ghana and 670 miles west of Gabon in the Gulf of Guinea. Who knew? It's actually been offline for like 2 months, which is kind of a bummer because I was going to show the real-time data. It's, the station number of this buoy is I think 13010, and you can pull it up just like any other buoy and in your stuff, which is kind of cool to be able to do that. But something tells me it's not much of a priority for them to go out and upgrade whatever's wrong on that. So if we take the view of the Earth and we think about it into two circles, right? So let's think about that circle looking down from the north. What do we have, right? To find out where we are, we go, if we went 90 degrees, it would be right out here. So we've gone around the circle looking from the north, 73 degrees. And if this is the equator across here, we've gone up at an angle of 41 degrees with some decimals put in it as well, okay? So when you put those two things together, that is the definition of how we get latitude and longitude, to figure out exactly where we are. And understanding latitude and longitude, how to add, how to subtract, that's the core of navigation, because everything comes back to what's my latitude and longitude, and what's the latitude and longitude of the point that I'm going to go to. Can we get through this, because we just kind of went through that one. For those of you who haven't been, this is Greenwich, England, on the left. So this is the prime meridian. So if you go back and look at this line right here, this runs directly through Greenwich, England, and that's called the prime meridian. And this is in Ecuador, the equator in Ecuador. Most countries have markers of where these things are. Most, if you're in a town that happens to have the equator run through it, they almost all have something. Here's Will and Reese, my two oldest. This one is looking north to the prime meridian, and this is now looking south. So Will is in the Western Hemisphere and Reese is in the Eastern Hemisphere. There's a bunch of pictures there with them like straddling them. Yeah, to be kids. So if you start at the prime meridian and you go east, that is referred to east longitude. And if you start at the prime meridian and go west, it's referred to as west longitude. Which means that since we're down here, that's why we are 73 degrees west longitude, right? Sometimes people refer to the anti-meridian, which is a line that you can imagine that would be back here, which would be 180 degrees east or west longitude. What's the other name that line is referred to by? Anybody know?
International daylight.
The international daylight, right? So that is where the day first starts. When it rolls from 11:59:59 to 12, the first place it does that is at the international daylight. Yeah. Similarly, going from the equator, you have north latitudes and south latitudes. So latitude is what defines how far north or south you are. The lines of latitude, let me go back here to this one. So longitude defines east or west, but the lines of longitude run through the poles. And latitude defines how far you are north or south, but the lines run parallel to the equator. Okay? So sometimes it can be confusing. So I've seen people who have struggled with the latitude and longitude thing. Matter of fact, I know a lot of people struggle with the latitude and longitude things because there's so many sayings about how to remember what is latitude and what is longitude. So here's a few of them. So first of all, coordinates are given as lat long, right? So latitude's first, north or south. Longitude second, east or west. Okay. So I always, one way to remember it is we're 41 north by 73 west. Which one came first? The latitude, right? Another one I've heard: latitude lines are all long, meaning they're all the same length, which means they run through the poles. So longitude lines run through the poles, and longitude defines how far you are east or west. I've heard it's a long way from pole to pole. I guess not like it's a long way around the equator as well, but it's harder to name a start point and end point, I guess. I've heard latitude equals latitude, that you have to climb up the ladder. So if you're climbing from the equator up to the North Pole, you have to climb up a ladder. Another way to remember that latitude are the lines that define north and south because they run east and west. My own personal favorite is Jimmy Buffett's song, Everyone's Got a Cousin in Miami. where he goes, let's take it down, boys, down south to those little latitudes, right? So that always reminds me that latitude defines south. Lateral side to side, right? And so therefore the lines of latitude run side to side across the globe. And the other one that I always remember is David Sobel's book, another required reading for any aspiring navigator. How many people have read David Sobel's book, Longitude? Holy shit, seriously? Nobody? Oh my God. Well, now you know what you have to go read next. It is one of the best, it's an amazing book. And we'll talk about it a little bit more. So let me pause for a second and see if there's any questions on latitude and longitude, because what we just kind of talked about is going to be foundational. And anything.
I have a question, Greg.
Yes.
When you were talking about the racing today, which I did not watch, and you said that sort of visually it looked like the two boats were in tie, but when the judges were looking at their screens, how far was it? It looked by the naked eye that it was saying how far apart were they?
I mean, I don't know, but I would guess it was inches. So the situation was, here's the start line. So the boats have to start going this way. And so you had the Swedes, so remember these are catamarans, and you had Japan just to weather with about 10 seconds to go. And so they had a camera angle that looked right down here. I mean, you were looking right across the stern of the Japan boat. So and you just couldn't tell. You couldn't tell by looking at it, right? And the Swedes flagged these guys. They said, look, penalty. We wanted to turn up, we couldn't because you were right there, and there was an overlap. So they put up their white flag, is what you do in the cup. And a couple seconds after they started, the umpire said no, right? And when he came on and talked, the head umpire said, it was close, but it was clear from our digital screen that there was no overlap. So what these guys have is on the front, they actually have a bunch more on that, but on the front and back of every one of their hulls, they have a GPS sensor. And that GPS sensor is tied into a graphic machine that's displaying real-time graphics on the race committee boat, so they can see exactly where all these things are, right? And the additional radio signal that they use to supplement this, it's definitely accurate to 2 centimeters. It could be accurate even a little bit more than that. I don't know. Pretty cool, huh? Other questions? No? We got latitude and longitude? Did anybody learn anything in that section? Yeah. Okay. Just want to make sure we're going the right way. So how do we know where we are? There's 4 ways that we can figure out where we are. And these are the 4 ways. We can do it by what's called dead reckoning. We can do it using celestial means, looking at the heavenly bodies and understanding where we are in reference to those. We can do it by piloting or pilotage, and we can do it with the help of electronic aid. We're all probably pretty good at this. The rest of them maybe not so much, right? Which is really why we're here, is so that people can understand, at least these 2, really how to do these 2 so that you're a better navigator here. Because the way I think about this, remember level of danger and certainty about my location, right? I can look at a GPS and I can say the GPS says that I'm here. It says that this is the point that I'm at. But you know what? I've lost my GPS before. I always carry on every boat. How many people have been on a boat that has lost their electronics? Only 1? 2? Nobody else? So I've been on a boat that has lost its electronics. Typically happens because of some water issue, improper wiring. And we went to power up the handheld GPS, which I always carry. Didn't have mine, we were relying on the boat one, and the batteries were dead. We didn't have any electronics. Now, luckily, we kind of knew where we were, and we were able to get to shore, but that stuff happens. And so, we were talking at dinner last night. The whole family came down to dinner along with my Danielle's parents. We ate at the Yard Bar. And I was talking to the kids about this class, and I said to Reese, actually, I said, one of the things I hope people walk away is that they're out in the middle of the sound, and it's foggy, and you can't see a thing, and the fog has shorted out all their electronics, that they can figure out how to get to shore safely. And I looked at her and I said, how would you do that, Reese? And she looked at me and she said, I don't know. I really don't care, Dad. Can I?
There you go.
All right. So we'll talk about each one of these just a little bit. Okay, so dead reckoning. And look, the concept of dead reckoning is, it's fairly simple, right? You know you've started someplace and you're keeping track of the time and distance. So I put this up, you walk 10 paces north and 6 paces east, then 3 paces south and 8 paces. That's dead reckoning, right? We start at Riverside Yacht Club and we go, we go southwest for 0.3 nautical miles, and then we go at a speed of 2 knots, and then we go, a course of 270 for 5 minutes at a speed of 5 knots, right? Keeping track of that information, that's dead reckoning. And so when we go through the plotting exercises, we will do dead reckoning. We will be able to start at a point and track. We go this distance for this long, this distance for this long, and we'll be able to track to see where we are. Right? And so part of the answer to the question, if you're in the middle of a sound and all of your electronics stop working, if you have not been dead reckoning, so what does dead reckoning look like? So when I would navigate sailboat races, I in addition to electronics, I dead reckon because we also use it for tactical reasons to look at things. But I go through and I'm plotting every probably 15 minutes exactly where I am. Maybe I'm using electronic fixes to support it, right? But I'm putting a point on a map. As a matter of fact, I used to have, I would have brought them, years and years of doing Block Island and vineyard races. I would keep the map afterwards. Whether it was Larry Dickey that was doing it, and I was doing it off watch, or I was doing it for somebody else. I mean, I had a bunch of maps of Long Island Sound. I actually had 2 of them. I had the western one and the eastern one, along with Block Island Sound. And it would have all the points of where we were and what time we were. So that's one way, but if you're not actually writing it on a map, you could know. If you know your boat does 20 knots, and you took off from the Cows, and it was, you took off from here and you're heading, east, and you're at the Cows, and I'm making this up, 10:30 in the morning, and then all of a sudden, fog sucks in, and all of your electronics go, and it's 11:15, you can dead reckon to say where you are. You can say, well, wait a minute, I know my boat does 20 knots. I haven't written anything down, but I know my boat does 20 knots, and I know I've been doing that for 45 minutes. So let me stop my boat and get out a chart and mark where I think I am, so that I can figure out what's around that I might be able to navigate to safely that's not right on the shore, that I would be able to find in zero visibility. What's that look like? Or what's that sound like? Right? Make sense? Okay, our first trivia question, Brent. Why do pirates wear patches? Anybody?
You have the answers written inside?
Anyone? Venture a guess?
The sightless stars.
Do they all poke their eyes out with their hooks? Or maybe my first day with the hook is you really
Keep their night vision. Okay.
Keep their night vision intact. One of the biggest things that I hear around the dock is people come to me and they say, I don't like taking my boat out at night because my night vision is terrible. I don't say this to people, but what I want to say is, no, your night vision is not terrible. You just don't know how to manage your night vision because it takes about 30 minutes for your eye to adjust when it goes from bright to dark. And the thing that drives me absolutely batty on my boat, and I just want to disable it, is there's one light switch. When people go down below, they hit the light switch and it puts white light. Like if you see on Serenity, the 2 lights that are above me are both red, because red light doesn't impact your eyes like white light does, right? That's why pilots have red flashlights. So it's not that your night vision's bad, it's that you don't know how to manage your night vision. So
there was a red light district.
Yeah, says a lot about your night vision. So here's why this works. So the human eye has about 120 million what's called rods that are photoreceptors, and 6 to 7 million cones, which are also photoreceptors. But they get different kinds of light. They work differently. And so that's this is a curve over here that says, if your rods only are what's sensing light, that's what you use for the majority of your vision, it's about 30 minutes from the time you introduce a different visual atmosphere to your rods until they've adjusted. Whereas your cones adjust to it in about 10 minutes. They don't get all the way there, but they get mostly there. So if you've never taken the time to make sure that you are in a true dark environment or dark environment with only red lights, so like I mentioned my red LEDs, so I have red LEDs, I always have a couple of red flashlights. What I even do, because I think electronic manufacturers are idiots, they just must not know about this, because on my Garmin, yes, you can turn down the light, right? But when you go from 18% to 17%, you suddenly can't see it anymore. And 18%, A, is too bright, and B, it's white light. It's a white background. There's no way to make it red. So what do I do on my electronics? It's a little chintzy, but it's what I do because I haven't figured out a better way to do it. Is I have a few of these red transparent sheets, and I just cut them to the size of my GPS. So if I'm operating at night, I turn it up to about 30, and I put that sheet over the GPS. So that I can still see just as good, but it's red light. And guess what? I can see at night pretty good. I get it dark, and I don't leave the dock until my eyes adjust.
So if you're running in the dark, no problem in turning on your red,
Yep, no
headlights,
problem.
if you will.
Yep, will not affect it. Make sense? Okay, before we did go there. Any questions about the dead reckoning concept? And I know we haven't gone into the detail of it because that's where the charting is really going to come in. But the way I want to structure this is before we go to the charting, we're going to talk about what's on a nautical chart. So this is kind of like laying the foundation. Any questions on dead reckoning or comments or on the concept of rods and cones?
So you got to keep a pretty good idea in terms of when you leave a mark, how long you've been running on that mark. So whether it's a stopwatch or something that you said, or
Yeah, it could be time. I mean, I do everything off the time of day. You know, it could be off an iPhone or a clock or whatever. You know, I typically don't run on how long has it been since I left that mark. You know, if I'm going to dead reckon something, you're right. We'll learn the language that you write when you do charting and do dead reckoning. There's a way that specifically you write things that should make sense to other navigators. It's not hard and fast. I see people. What's more important is that if you go back and look at it, you're able to tell a line of position, which means an angle that you've taken off of some fixed mark on shore versus your course, and whether your course is magnetic or true, which we'll talk about now. Yeah.
So when you have a red light as opposed to a white light,
Mhm.
is it just easier to see and like better to see, or does it also like affect your eyes like negatively going forward if you use white light?
Yeah. So red light will not harm your night vision. Right. So if you've taken the time to be in a dark environment, right, and you turn on a red light, that red light will not impact your ability to see. And it's not exactly this way, but this is the way I learned it when I was flying. The rods are what you see with in this kind of light, and cones are the primary thing you see with when it's dark, right? So they're a different kind of receptor. So if you turn the light on, right, that's all of a sudden your cones are going to take a while to be able to reset. And so they're also color sensitive though. Red's not the only color that does it. There's certain things in the blue spectrum as well, but red is the default, right? Like green is also a common. But if you ever stick your head in a cockpit of a commercial plane when you're getting on it, you know, it's really dark and the only lights you see are red in nature because that's, you know, they're getting their night vision in gear. Yeah. So,
And most decent headlamps nowadays are sold with either a red
Mhm.
cover or the option to choose red.
Absolutely. Yeah. And it's much better. So sailboat racing, for example, if you're going to be out at night, right, you're going to have your headlamp on and you're going to be trimming a spinnaker or whatever. You know, you don't want to turn around and put your white headlight into the skipper because he's not going to be able to see anything, right? And so it's having that red. Now, obviously, red doesn't illuminate quite as well as white does, but you know, that's a trade-off. That's probably a good thing to make. Okay.
Just an observation, as you're going through this, I'm thinking, I don't have that on my boat, I don't have that on my boat, you know, it's just like a basic, because I rely on electronics and I have a handheld GPS and my phone, but still not having at least a book, you know, a couple pencils ready to go.
Yeah, and so a couple of things. Remember back to level of danger? I feel that I have a lower level of danger operating at night than most people for a couple of reasons. Number one, I understand night vision and how it works. I understand the impact that a white light can have, and I have stopped before. I've said, you know, we're gonna, you know, not go crazy fast coming back from the fireworks, you know, because my night vision's not where it needs to be. We're gonna slow cruise for the first 10 minutes because I don't want to be doing 25 knots if my night vision's not 100%. The other thing that I have on my boat, anybody else have FLIR? People know what FLIR is? You know, forward-looking infrared. And so if people look at Serenity, in the middle of Serenity, there's what looks like a camera right on the center line. Nick's boat is kind of like thing that's about that big around in white that has a little dome on top of it. And it's called forward-looking infrared. And so there can be zero ambient light. And I don't care if your eyes are adjusted. There's truly zero ambient light. There's nothing to reflect it back. You can't see. It's dark, right? Unless you have FLIR, which is infrared, so it goes on heat. And another thing, I run with my FLIR on during the day. I don't know if FLIR has ever saved my bacon at night, but FLIR has at least one time for sure saved my bacon during the day. And I'll tell you a situation. I was coming back into Captain's Harbor, going over to Bellhaven at sunset, very near sunset. So I was going right into the sun. And some Darwinian-influenced individual was south of Red Rock on a paddleboard, blue suit and a blue paddleboard. And I happened to glance down at my FLIR, and I saw a heat image. And I'm like, what the hell, right? And so I shut the throttles down and kind of turned hard to port. And sure enough, once I got out of the angle directly in the sun, there was this guy paddleboard. I don't know if I'd have seen him. I really don't know if I would have seen him. And so I run with my FLIR during the day because people who decide to do those kinds of things, I'd rather not run them over. So I'm a big proponent of FLIR. Joe, you look perplexed. He wasn't. He wasn't. I guess he was allowed to be there. Okay. So let's see what time it is. Do we want to take a bio break, or do you want to keep going and you guys just self-regulate bio breaks? Keep going. Okay. Oh, stop. Go back. Let right for that. So now we're going to shift and talk a little bit about celestial. So before we go on, any more questions on dead reckoning? The concept of dead reckoning. Okay. Good. Okay. So let's talk a little bit about celestial. So the sun, as far as I know, as long as the Earth has been here, has always been coming up. And the stars have always been moving around, and they've always been doing it in pretty much the same way. So you can tell that that's the North Star right in the center of that thing, because this is a time lapse at night, right? And so, we can use the position of those and other celestial bodies. Your capacities around. In case anyone's never seen a long-term almanac book of celestial stuff, pass those around and take a look at them. We know where those are, right? So the North Star, what can you say with pretty good confidence about the North Star, given what it looks like in that time lapse? What's it above? The North Pole, right? Because if it wasn't directly above the North Pole, as we rotate, it's going to look like one of these over here. It's not going to look like that little dot in the center of the screen. And so, if we know where the North Star is, and we know how high the North Star is off the horizon, we can figure out pretty closely where we are. If we know sun at sunrise or sunset, we can figure out pretty closely where we are. If we know what time sunup is going to be, and we know that it is the summer solstice, which means we know exactly the tilt of the Earth, we can figure out with its geometry, and it's not even that complex geometry, to be able to figure that out. And that's really what celestial navigation is all about. Probably the most common one, and so I actually hadn't done celestial navigation in a while, and I was also pissed because I have a really nice sextant that either in our last move or the move before went missing. And so I also have this. This is a plastic one, but it's a really good plastic one. I mean, they make cheap plastic ones, but this one's a Master Mark. It's a 15. I can't remember if it's a 15 or a 25. But I've taken some noon sights with this in the last couple of weeks. So you can pass it around if you want to. And I was in RYC one of them. I mean, that's pretty good with a plastic sextant and not having a true horizon to be able to get 5 or 6 miles off. And so knowing the sun when it's at the meridian, when it's directly north and south of us, when it's directly on our longitude, our line of longitude, is valuable because you can measure the height above the horizon, and if you know the time, exactly the time, you can figure out where you are. By the way, with that one site, mariners in the Royal Navy, to be qualified as a mariner in the Royal Navy, with the noon sun sight, you have to be able to consistently navigate to 1 nautical mile. If you can, I don't know if the podcast was. Bob, do you remember your accuracy on noon sights back when you were doing?
You know, we had a periscopic sextant,
Yeah.
which gives you a average because your aircraft is moving up and down.
Absolutely. Yeah.
So when you talk about measuring how far up the North Star is, how do you determine that from the sextant?
That's what a sextant is used for. Yeah.
Okay.
I'll get there. I'm going to explain a sextant in just a second.
Okay.
Okay. Here's a neat trick, by the way. If people aren't familiar with the shadow stick concept, Joe, you probably are because you probably learned this in Eagle Scouts, right? This is how you can find out where true north is, right? And basically a sextant does the same thing as you do with a shadow stick. So what's a shadow stick concept? So if you can imagine this bottle sticking up, and imagine the sun is over here, and I either on dirt or on a piece of paper, I mark as the sun transits across the sky. And when this here is the shortest, it's going to point directly towards true north because the sun will be over my meridian, over my line of longitude. That's the same thing you're doing with a sextant, except instead of finding the shortest line, you are finding the highest point in the sky when you take an insight. That's what you're doing. So what do you need to be able to do this? I mean, there's crude ways. I mean, there's great navigational stories, and I love reading the books like Adrift, and I mean, I've read all these things about these guys who survive hundreds of days out at sea after being shipwrecked or whatever. I mean, you don't need an accurate sextant. You can do it. You can do it like this. That's I'm going to forget this. That's 2 degrees. That's 5 degrees. That's 15 degrees. You're holding your fingers at length. Right now, if I put the bottom of this finger right there, the top of the finger is approximately 15 degrees above the horizon. I've got a mini sextant right in mine. Unless you have fat fingers, Joe. All right. So you need to know the angle of a celestial body, and you need to know what time it is. So I thought I had a different picture here. No, I don't. Okay, never mind. So I mentioned that I would talk a little bit about this. So time is a very important thing for navigators, right? And we'll talk about the accuracy of time today, how accurate time really is. But if you go back to the 1700s, it was really, did I put the year in here? I didn't. I want to say right, it's down the bottom. 1736 is when he first came up with these, right? So it was the late 1700s when a guy by the name of John Harrison, with what's called H4, solved the time problem. So there used to be a prize in England, and that's what the book Davis Sobel's Longitude is all about. Is the question was, how do we solve the longitude problem? Because no one could figure out how to tell how far east or west you were. They could figure out how far north or south. You could not figure out east or west. And so there's basically 2 methods that were being tested at the same time. One was using moon position, because since the moon is always in a relative place different from the sun, you could measure that relative difference. So if you knew you left on this day and it was this day, you could measure the change in the relative distance between the sun and the moon, and you'd be able to calculate with some more complex geometry what your longitude was. Or Harrison's concept was, if I knew exactly what time it was, right, I would be able to tell where I was, because if I'm at the prime meridian at noon, where's the sun going to be? Directly over my head. Okay. If I am here, and I'll show this calculation in a second, at 12:50 in the afternoon, which is really 4:50, and I can figure out my launch because I know how much time has passed, and I know that the Earth rotates 360 degrees in 24 hours, so I know it rotates 15 degrees every hour. You can figure out exactly where you are, right? And so H4 made a trip from England to Cuba, I think was their first destination, and was still accurate to within 3 seconds. And people are like, okay, what's the big deal? It's a clock. right? This thing's accurate to, right? Well, it wasn't electronic, it was mechanical. It had to be able to work in seas that move and humidities that varied widely and